whenever there is a change in temperature, there will be the change in resistance of that particular system. So guys, resistance will be there inside that conducting media, always there. The first one, conducting medias are over here, which is used. It can be copper, nickel and the platinum, which are very widely used metals over here. So guys, this is the simplex form of a RTD. Basically over here, this sensing bulb, or we can call it as a RTD bulb, which is also known as the RTD element, which is very typically made up of platinum, hence it is known as the PT100 element basically. And guys, this gives us a reading by change in resistance on a voltmeter or ammeter basically. So guys, this is how this RTD works basically. The second one in the electronic measurement is the thermocouples. So guys, thermocouples is the formation of the couples that is known as a junction with the help of these two dissimilar metals. So guys, these two dissimilar metals produces the different voltages. So guys, the EMF gets induced at the opposite end of the junction. So guys, this is the opposite end of the junction basically. So the temperature of this particular end is the ambient temperature, and the temperature of at the junction is always on higher side. Let's say it is T2, hence this T2 is always greater than T1. So guys, this dissimilar metals produces this EMF produced at these two different points basically. So guys, this EMF induced is known as this Seebeck effects. So guys, this Seebeck effect is the primary aspects in this electrical measurement system. So guys, over here we have seen this industrial measurement system, that is the mechanical and electrical measurement systems we have seen. So guys, I hope you understood the temperature measurement system which is used and adopted by the lot of various industries. So guys, I hope you understood this video. If you have any doubts and queries, please do comment below guys. So guys, thank you for watching my video guys. Please do subscribe to my Hey guys, welcome back to another video of Engineers Academy. So guys, in this video we are going to learn the how bimetallic thermometers works basically, and what are the specifications and how the bimetal thermometer are specified. So we'll learn the specifications also. So guys, before going to our today's topic, I request you to please consider subscribing. So guys, subscribe my YouTube channel Engineers Academy and learn engineering with all the topics of engineering. So guys, our channel is completely dedicated to engineers. So students, teachers, working professional, for all those our channel is basically dedicated. So guys, let's begin with our today's topic, that is how bimetal thermometers works. So guys, it is also known as the bimetal temperature gauge. So guys, it is the mechanical measurement system. In the last video we have seen in which the mechanical arrangement is there, in which this particular bimetallic strip which is used so to measure the temperature by the means of this bimetallic helix basically. So guys, over here in this case this bimetallic strip in the form of helix is used. So guys, over here in the strip the two dissimilar metals are joined and fused together to form a bimetallic strip, and it expands with the increase in the temperature, and it deflects the pointer which shows a reading on a scale basically. So guys, but why this bimetallic strip consists of two different metals? Why not the single different metal? So guys, let's go in history that we have conducted an experiment. This is the ball and a ring. So guys, whenever we hit the ball, first of all it can passes through the ring easily, and after hitting it won't pass through the ring. So guys, through that particular experiment we can understand a solid expands when heated and contracts when cooled. So guys, this is the basic principle behind this working of bimetallic temperature gauge. So guys, whenever if we use a single metallic strip over here in case of bimetallic gauge, can gauge comes down quickly to 0. Whenever if suppose the temperature gets reduced, can this pointer comes down quickly to 0? The rate of contraction over here matters. No, this it won't comes over here directly and quickly to 0. So that's why guys, the bimetallic strip which is used. So guys, in the bimetallic strip there are two different metals having low expansion coefficient and high thermal expansion coefficient. So guys, these two different dissimilar metals, one is used for going temperature up and second is used for going temperature down. So guys, this is the industrial representation over here. This is the how a gauge actually looks like. So guys, let's check out the specifications of this particular temperature gauge. The first of all, the dial size. So as we have seen in the pressure gauges, the dial size can be of 2.5 inch, 4 inch and 6 inches. The temperature range over here is as per the standard. The standard which is used over here is EN 13190. It is the standard for the temperature range. The next one is the mounting type. So guys, the mounting which I have shown over here, this is the direct bottom type. It can be changed like from the back entry, like the horizontal arrangement of the temperature gauge. This is the back entry type and the vertical is the direct bottom type. It can be of the all angle, like it can be viewed from every angle. That's why it is known as the every angle type entry. Over here this Vickers gauge is having every angle type. So guys, this mounting type can be of direct bottom, back entry or every angle type. So guys, moving next is the stem diameter. So guys, the stem dia can be vary from 6 mm, 8 mm and 10 mm guys. So over here this is the stem diameter basically. Thus, apart from the stem diameter, next is the stem length, which can be vary depends upon the requirement of the customer, that is from 100, 200 and 300 mm. Next is the process connection. So guys, the process connection is how can we fix this upon our requirement or the equipment. That can be half inch BSP or NPT. It can be anything that is fixed or adjustable. So guys, these all are the specifications which are needed to specify this bimetallic temperature gauge. So guys, over here this glycerin filling is not possible in case of bimetallic temperature gauge. So guys, over here in this video we have seen the construction of this bimetallic temperature gauge and the specifications we have seen over here in this video. So guys, I hope you understand very well how does this bimetallic temperature gauge works. So guys, don't forget to hit like over here, and if you having any doubts and queries, please comment below. Okay, and please do share all my videos to on the social networks to your friends, families and to all the engineers. Also guys, don't forget to subscribe my channel Engineers Academy guys. Thank you for watching this guys. Hello guys, welcome back to the another video of Engineers Academy. So guys, today's topic is the mechanical measurement system that is nothing but the gas filled temperature gauge. So guys, in this video we are going to learn the working of this gas filled temperature gauge and its specifications. But guys, before going to today's topic, I request you to please consider subscribing and press the bell icon so you will get the latest updates over there. So guys, let's begin with our today's topic, that is gas filled temperature gauge. So guys, over here in the gas filled temperature gauge, it works on the basic principle of this sensing bulb. Inside that sensing bulb, this nitrogen, that is called as inert gas, is filled over there, and the mechanical system over there, which is the system is fully filled with the gas, that is typically nitrogen gas. And whenever this bulbs the temperature increases and this bulb senses the temperature, the inert gas which is there inside that bulb, it expands, and as the gas is fully filled in the system, it also expands this Bourdon tube basically. So guys, this basically over here, this is the connecting link which is connected from the end of the Bourdon tube and to the mechanism, that is the pinion. So this connecting link, due to that connecting link, the pinion rotates and the pointer gives us the reading on a scale. So guys, this is the overall working of the gas filled temperature gauge. Over here, this is the industrial representation of the gas filled temperature gauge. And guys, this is the remote mounting capillary. So the typical length of the capillary ranges from 3 meters up to 20 meters basically. So guys, this capillary type is over here. This is the armored type capillary. So guys, there are two types of the capillary system. First one is the armored capillary and the second one is the covered capillary. So guys, over here this capillary is having the armor basically, so that's why it is called armored. And the next one is the covered capillary. So guys, there is no armor on the basic microbole capillary. So this one is the basic one, that is the covered capillary, which is shown over here in this image. So guys, but it's not advisable to use without armor. It is always used without covered armored capillary. So basically that's a good engineering practice. So let's check out the specifications of the gas filled temperature gauge. So guys, over here this is the temperature gauge. The first one is the very important, that is the reference standard. Every manufacturer has to compile the reference standard, that is EN 13190. Then sensing system can be of the gas filled or liquid filled sensing system. The dial size can be ranging, it can be of 4 inch and 6 inch. Gas filled cannot comes in the 2.5 inch. The temperature range always corresponds to the standard, that is EN 13190. The next one is the mounting type, that can be of the direct bottom, back entry, or the surface mounting. So guys, over here this image shows us the surface mounting, and over here this the Ashcroft model. The vertical model is of the direct bottom type, whereas this is the horizontal model, that is with the Vanstone thermowell, which is back entry. So guys, over here in this image, this is the surface mounting. So whenever surface mounting comes, you need to understand the capillary always will be there. The next one is the process connection, that is the threaded half-inch BSP or NPD or any other as per the requirement of the customer. So guys, over here this is the ACF is the provided, that is the process connection. Over here you can see this is the process connection of the gauge. So guys, the process connection type is also matters over here, that can be the fixed or the adjustable. So guys, this particular ACF, that is the adjustable compression fitting, it slides over this stem of the temperature gauge. So next is the stem length. So guys, the stem length or the stem diameter. So stem diameter can be of 6 mm, 8 mm, 10 mm, whereas stem length varies as per the requirement. So guys, these are all the mechanical specifications, or we can call it as a mechanical aspects of the temperature gauge. Apart from that, over here the material is also important. The material, that is the material of the inside Bourdon tube, which is also important, which is always will be SS 316L, which is also comes under the specifications. The next one is this case and bezel material, that is the SS 304, or we can also provide the 316, depends upon the requirement. And the material of this capillary, that is the SS3 armor material, is SS 304, whereas the microbore capillary is having 316. The material of the stem will be always SS 316. So guys,